Okay, hi you guys. So I'm going to show you how to write a function called addBinary, and it's going to take two binary numbers as strings, and it's going to output the sum in binary. So I'm going to write this in JavaScript in ES6. And the reason why we want to have the input as strings is because when there's a 0 in front of the number, what JavaScript does is it converts it to octal. I can show you this if we console log 0 and 0, you think that might output 10, but it's actually going to output, it's actually going to be 8. So we don't want that. Alright, so let's delete that. So we're going to help define our function, add binary, and it's going to take two numbers, A and B, and we're going to output those two binary numbers, the sum of that. So if A and B were regular decimal numbers, we would just do A plus B, and that would be it. However, that's not going to work in this case, but a simple fix will do it. So if we use Parse Int, what Parse Int does is it converts a string and outputs a number, but it's going to output that number in decimal, and it's going to assume the number you're giving it is also in decimal, or the string version of that number. But Parse Int takes a second parameter that allows you to let it know the base of the string form of the number that you're giving it. So it's letting it know that what we are giving it is in binary. Okay, so now what this is going to output is actually going to be the decimal base 10 version of that number, and that's not what we want. We can write a test first and show you. So if we have add binary, and let's say I give it 1, 1, and 1. So this is 3 plus 1. It should output 4. So we can test it out. Oops. Oh, that was. Oops. Okay. There we go. And it's going to output 4. But we really want it to output 1, 0, 0. So that's easy. We can just take this and use toString and convert it to a string. And toString takes an optional parameter, oops, a base that you want the output to be in. So we want our output to be not in base 10, but in base 2. So we give it 2. The default is 10. And there we go. Okay, so this is a very easy and elegant solution. However, it might kind of feel like cheating. So if you want to write a solution that manually adds each bit together, we can do that. So let's call our function let add binary manual, and I'm going to call it big A and big B, so that every single bit we're adding, we can call that little a and little b. Okay, and so basically what we're going to do is we're going to take each binary number and we're going to loop through it concurrently. We're going to loop through A and B concurrently, adding the rightmost bit to each other, and then concatenating that to a sum. So we're going to let sum equals empty string, because we want our solution to be a string, our output. So we're going to return sum at the end. And then we are going to loop through. So we need two indices. So we're going to let I equals the index for A, and because we're starting at the right and not the left, we wanted to let it to be A dot length minus 1, which is the rightmost index. because when we add numbers, we add right to left. Same with B. We're going to call it J for B's index. B.length minus 1. Oops. Okay. We are also going to have a variable that's going to carry it's going to be the bit that we're carrying. So let carry, and it's just going to be 0, and I can show you why it's not a string. So we're going to use a while loop instead of a for loop, because we want it to be as long as we have there's still bits to look at in one of the numbers, or one of the binary numbers, we're going to continue. A for loop would work if both A and B were always the same. We could still write it that way, but I just think a while loop would be cleaner. So while I is greater than or equal to 0, or j is greater than or equal to 0. And then we want to make sure with each loop we want to decrement I and j. That way we won't get stuck in an infinite loop. Okay, so yeah, so carry is going to keep track of our carry bit. So now I'm going to define little a to be our bit at index I, and let b equal to the same thing with respect to b. And so for this, you know, you might think we would have a bunch of if-else statements to check. If a is 0 and b is 0 and carry is 0, then the output should be 0. But we could look at this data by writing out a simple truth table to take a look at what we want, what our input would be and what our output would be. So our input would be, we have an A value, a B value, a carry, which I'm going to call C, and that's going to total up to a sum, and then a new carry value. So if everything is 0, we want our sum to be 0, and we want our carry to be 0. If everything is 0 except for the carry, then we want our sum to be 1 and our carry value to be 0. If one of the bits is 1 and the other one is 0, and carry is 0, then it's going to be the same thing, 1 and 0. If one of the bits is 1 and the carry is 1, then we want our sum to be 0 and carry to be 1. If both of the bits are 1 and carry is 0, we want our sum to be 0 and carry is 1. If everything is 1, then sum is going to be 1 and carry is going to be 1. And that pretty much takes care of all of the possible inputs. So if we take a look at this, the operator that would produce the sum consistently would be XOR. So XOR is a bitwise operator, and it is the symbol is this caret, and it basically is going to be it's basically, if the bits are the same, then it's going to be 0. If the bits are different, then it's going to be 1. So we can see 0 XORed with 0 is the same, so 0 XORed with 0 again, it's 0. And we can see that works. We can try something here. For instance, 0 XORed with 1 XORed with 0 is different, so it's 1, and then 1 XORed with 1 is the same, so it's 0. So it actually, if you go through it, it works for all of these, and the order doesn't matter. So, I mean, in which order you XOR the A, B, and C. Now we just have to take care of carry. Well, if you notice here, carry here is 0, and here it's 0. The only times carry changes is actually here and here. Those are the only two places that it changes. So instead of having a bunch of like statements of if A is 0 and B is 0 and carry is 1, then flip carry, we notice that in both of these situations, what it shares in common is that A is both equal to B and the opposite of C. So when that's the case, we're going to flip carry. So, and we're going to use that logic inside our loop here. So first, sum is going to be equal to A XORed with B XORed with C, or carry. And the moment we XOR A and B, so A and B are currently strings, then it's going to be converted to a number, which then XOR to carry. Now this whole thing is going to be a number, so we need to convert it back to a string. Okay, and then we're going to add it to sum, because we're adding from the left. Okay, and now if A is equal to B and A is not equal to carry, and this time we need to convert it string form of carry, then we are going to flip carry. And the way we're going to do that is we're going to say carry equal to not carry, but we're not done yet. Not carry is going to produce a Boolean value. Okay, so not of 0 is going to be true, and then not of 1 is going to be false. Now we can convert it back to a number just like this, because when we try to convert true to a number, it's going to be 1. When we try to convert false to a number, it's going to be 0. Great. Then, after it's done looping, we have to remember there are situations where there's still the carry value is still 1, and we want to make sure we include that. So if carry exists, instead of saying if carry is equal to 1, we can just say if carry, because otherwise, if it's 0, it'll just pass through. So if carry exists, then we are going to say sum is equal to carry plus sum, and that will be the string form of carry. Okay, there we go. Of course, you can also do the logic here if you wanted to. We could do, let's see, if you wanted to, you could do if carry, then do string carry plus sum or sum. Why is that color? I'm not sure why. Okay. So basically this says if carry exists, then we're going to do, actually it's probably because I need parentheses around here. There we go. If carry exists, then I'm going to say string carry and then add it back to sum and return that. If not, if it doesn't exist, then we're just going to return sum. Okay, but personally I like using this if here better because it's just a little bit easier to read. So we can test this out. Let's say, so addBinary manual, oops, and there we go. I'm going to show you. This is going to give us the same thing. So that works, and you can see if I just undo this, return sum, and then that also works. Okay, but if let's see, if I were to take out this and then build it, oh, it still works. If I were to give it a different value, let's see, like that, now you can see they're different because the second one is inaccurate. This is because when A and B are different lengths, in this case B, here, after the first loop, B is going to be undefined. So it's going to mess up the logic in there. So this is still going to, yeah, this would still actually work for this line 16 right here, because A XORed with undefined is just going to be A. So it'll just fall through and it'll still be fine. It's this part that doesn't work. A, even if A is 0, it's not going to be equal to undefined ever. So we can do a quick fix right here. We can say let A equal to this value if it exists. So we can have a ternary statement there. If it exists, then it's going to be equal to that same thing. Otherwise, we're just going to have it be equal to 0, because we're just basically adding zeros, oops, onto the front of the number that is not the same length, the shorter number. And we can save and build, and we can see now it works. Okay, so there we go. So that is the manual solution for binary manual. We can test a couple more values just to see. So actually I'll just change this in here. So we can try a few edge cases and test to make sure they are the same. So, and you can see that also works. And you guys can play around with it yourselves. So now if we look at the time complexity, what do you guys think this would be? Time complexity. So we have one loop, and in every single loop, we are basically just going through the longest binary number. So our time complexity here is just linear. As for space complexity, here are our variables, and we can see that it's constant. So space complexity is constant space. Okay. Yep. I'm not sure actually what parse int and toString. I'm gonna guess that parse int is linear and toString is linear. So this whole thing is still linear there. But using functions, function calls are much more expensive than a simple loop. So this one is actually, aside from using string and number, would be more efficient, maybe. Because we're using string and number, I'm not sure. Yep, that's basically it. Okay, if you guys have any questions, comments, or suggestions, or if I made any errors, please let me know. If you know the answer to those questions at the end that I'm not sure about, please also let me know. Okay, great. Thank you so much for watching, guys. Okay, bye.